Hi everyone. Now let us learn the next method, that is Gauss-Seidel iteration method. This method is a modification to Jacobi iteration method. Now let us consider a system of linear equations. We have to arrange the system in a diagonally dominant form wherein the coefficient of x, y and z are the largest in equations 1, 2 and 3 respectively, and write down the equations for x, y and z the same way as we did in Gauss-Jacobi iteration method, and number the equations. Having numbered, assume the initial approximation x0, y0, z0 as 0, 0, 0. Now unlike the Gauss-Jacobi iteration method, in Gauss-Seidel, as we keep finding the values, we are going to keep on substituting those values in the next step itself. In Gauss-Jacobi, x1, y1, z1, that is the first approximation values were found using the initial approximation thoroughly. But in Gauss-Seidel iteration, the first approximation values will be found as we keep evaluating them. That is, if x1 is found, then in y1 equation, if there is an x, we have to substitute x1. z1 is not yet found, so we'll take it as z0, then z0 will be 0. So if we take z1 equation, 1 by c3 into d3 minus a3, x1 is already found, so substitute x1, y1 is also found, so substitute y1 here. So it would become minus a3 x1 minus b3 y1. That will give us the first approximation of this solution. This way we have to continue and proceed with the other iterative values till the desired accuracy is obtained. Now let us see a problem. So using Gauss-Seidel iteration method, solve the system 27x plus 6y minus z equal to 85, 6x plus 15y plus 2z equal to 72, x plus y plus 54z equal to 110. By inspection, we see that equations 1, 2 and 3 are already having largest coefficients for x, y and z respectively. Now the given system can be written as x equal to 1 by 27 into 85 minus 6y plus z, y equal to 1 by 15 into 72 minus 6x minus 2z by 15, z equal to 1 by 54 into 110 minus x minus y. Having written the equations for x, y and z, assume the initial approximations x0, y0, z0. So in equation 1, x1 is equal to 1 by 27 into 85 minus 6 y0 plus z0. y0, z0 is 0. So that will leave us with 85 by 27, that is 3.1481. Proceeding to the next value, y1 is 1 by 15. Now x1 is found. So immediately substitute x1 in the next step itself. 1 by 15 into 72 minus 6x1 minus 2z0. So x1 is 3.1481 but z0 is 0. So by simplifying, we'll get 3.5407. In the same way, z1 is equal to 1 by 54 into 110 minus x1 and y1 is already found. So immediately use it up, substitute it. So minus x1 minus y1. Substituting these values and solving, z1 is 1.9131. Proceed with the second approximation. Find x2. x2 will now be 1 by 27 into 85 minus 6y1 plus z1. So substituting the values, it gives us 2.4321. Similarly, y2 is equal to 1 by 15 into 72 minus 6x2 minus 2z1. Because x2 is found, so we are using it immediately in the next step by substituting the values for x2 and z1. y2 is obtained. Similarly, Z2 is 1 by 54 into 110 minus X2 minus Y2. X2 and Y2 is obtained in the previous step, so immediately we are substituting in Z2, and that gives us 1.9258. In the same way, proceed with the next iterative values as X, Y, Z values are not converging yet. Hence, X3 is found, Y3 is evaluated, and Z3 is evaluated using the formula as given here. And compare X values. X2 is 2.4321. X3 is 2.4256. So they are getting very closer. Y2 is 3.5720. Y3 is 3.5729. So almost 3 decimal parts have converged. But Z3 is 1.9259. Z2 is 1.9258. They have also converged, but X value hasn't converged. So till all the three values of X, Y and Z converges, we have to proceed with the iterative values. Hence we proceed with the next iteration, X4, Y4, Z4. And we see that with X4, Y4, Z4, the values of X, Y and Z has converged. Approximately 3 decimal parts have converged. 2.4256, X3 2.4255. Similarly, Y value is 3.5729, round off becomes 3.573. Z4 1.9259. So at this stage we can stop the iteration, but just to show you that the values will repeat after this in the same way. Here we have X5, Y5, Z5 and the same values are repeating. So the advantage of Gauss-Seidel iteration method is at a very less number of iterative steps, the values reach a desired accuracy compared to Gauss-Jacobi. If in Gauss-Jacobi the iterations would be around 8, in using Gauss-Seidel iteration method, the values will converge at the 5th iteration itself. Hence, given a choice, Gauss-Seidel iteration method is definitely time saving, and time management, you all know, is very important with numerical and statistical methods paper. So Gauss-Seidel iteration method gives us the solution at a very early stage. Thank you.